So, in the previous class, we have discussed on continuous uniform distribution, right? So, in this case, we have seen the uniform distribution. Okay. So, for the probability density function PDF, f of x value is said to be k, and that is given by 1 by b minus a for the limits from a to b. 0 for that we have seen. The proof of that we have seen k equals to 1 by b minus a, and the cumulative distribution function CDF also we have seen x minus a by b minus a. So far, any doubts in this? Variance and all that. Clear to you all? Yeah, if that is clear for you, then we'll go for numericals. So, discuss the first problem already in the previous class. Let us look at the second numerical problem. Okay, so everyone can see the screen, right? Shall we begin the second problem? Hello? You can see? Yes. Okay. Right. So look at this problem. The amount of time that a person must wait for a bus is uniformly distributed. Okay. This already I told you to go through it. So if you have gone through it, it's fine. If not, let us look at that. It's like when you are trying to understand these questions, right? You need to feel like you, not somebody else. Okay. Is that clear? So the amount of time that a person, when you're talking about a person, you feel like it's you. When you are waited for a bus, like you are waiting for a bus. So when you're waiting for a bus, that is uniform distribution. Because you may start with some point and end up with some other point. So from one time to other time only you will wait for the bus. You will not wait for the bus full day, or you will not wait for the bus full month, right? It's a limited time. Okay, from let us say point A to point B, you will wait. After that, you may not wait because you got the bus or you change your plan, right? So that's how the question it is. Okay. Now, write the probability density function. You need to write this probability density function called PDF for this. Write PDF probability density function for this first one. Second, find the probability that a person has to wait before 4 and 6 minutes from the bus. So you need to find the probability density function for everything. Second, you need to find the probability density function, or let us say the probability which will be from 4 minutes to 6 minutes. Not everything, not 10 minutes like that, from 4 to 6, that's all. And C, find the probability that a person has to wait between 3 and 7 minutes. So you need to wait for 3 and 7 minutes. So what is that is going to happen? Between 3 and 7 minutes. Before above it is 4 and 6 minutes. Now it is 3 and 7 should be. And also you need to find the probability that a person has to wait for 0 and 10 minutes also. So this is what we are trying to find from this. Okay. Now let us see further. The x value is the number of minutes a person must wait for a bus. So x value, the number of minutes a person must wait for the bus. The value a equals to 0 and b equals to 10. From a equals to 0 to b equals to 10. That's are the 2 points, a and b. Okay. And the x value will be around ranging from 0 and 10. So now we need to find the probability density function for it. So that is called as PDF, probability density function. We call it as PDF. Okay. So f of x will be equals to 1 by b minus a, correct? B value is 10, a value is 0. So 10 minus 0. Right? So 1 by 10 minus 0 for 0 less than x less than 10. Okay. Now, so what is the value of that? It becomes 1 by 10. 1 by 10 will be 0.1. Correct? Any doubt in that? A is clear, A point is clear. So any doubt with this so far? A point A. Hello?
No doubt.
Fine, good. So good going. B. What is the question B? The probability that a person is like you feel yourself, like probability that you have to wait between 4 and 6 minutes. Out of 10 minutes, I just want to find the probability from 4 to 6. That's all. In that case, what will happen? So as we have seen the formula, x minus a by b minus a, x value because the highest of that x. Okay. So 4 to 6 minutes we told, right? So 4 to 6. So 4 minus 6 we wrote, and b minus a down we wrote there. Total on total, it is 10 minus 0. So it is 4 minus 6 minus 4, 2 by 10. It is 0.2 or 1 by 5. Correct? So that's how it is. Now next you want to find 3 to 7. Same formula, replace the values of 4 minus 6 as 7 minus 3. And the denominator will remain same. And you may ask, sir, a value, here it is 0, here it is 3. A value, here it is 0, here it is 4. When we are talking about x minus a here, the upper limit. So with respect to this one, 4 and 6, upper limit here. 4 is lower limit, 6 upper limit. And we talk about the complete 10 minus 0, like this. Okay, fine. Similarly, when you want to do it for 0 to 10 minutes, so when we talk about 0 to 10 minutes, what will happen? That will be 10 minus 0 by 10 minus 0. Total probability is going to be 1. Any doubt with this problem? Is that clear? It's very simple and straightforward. It looks very difficult when you see the question, but when you look at the answer, it's very simple. Okay? Here's the question. So this is the question. Second one, the amount of time taken for a person to wait for the bus. So this is the answer. So any doubt with this A, B, C, D, any one of them? Hello? Hello? Is that fine?
Yes, sir.
Yeah, one more thing I would like to know, some students were not attending the classes. So if they are there, let me know. So as per my observation, maybe some to the 90% accuracy. Arif, I cannot see Arif. Ashok, Stella Satish Naidu, Stella Shiva, Guru Kiran, Jyotik, Dhanushri, Venkata Sai, US 48 Kamireddy, 57 Charan. Any one of them are there now? So no. So it's been observed that they are not attending the classes. So it's very important to attend. Okay. If you have any difficulty in attending, please do inform and communicate it. Okay. Right. So I'll just call the names at the end of the class. Let's join. Let us see. Okay. So this is the third question. Third question: in an apartment, the person is taking an elevator to reach his floor. What is his floor is not mentioned, right? So a person is okay. An apartment, the person is taking an elevator to reach his floor. Once he called the elevator, which means he pressed the elevator button, it will take between 0 to 40 seconds. If I press an elevator button, it will come immediately in fraction of seconds. It may be open 0 seconds, or it may take maximum 40 seconds. And assuming that the elevator arrives uniform distribution between 0 to 40, it may come anytime between 0 to 40 after pressing the button. Now, what is that they're asking? Write down the formula for probability density function. We call it as PDF f of x, the random variable x, representing the arrival time. Representing the arrival time. Okay. Right. Now, the question, calculate the probability that elevator takes less than 15 seconds to arrive. What is the probability if it takes less than 15 seconds to arrive? B. C. Calculate the mean and variance of the distribution and find the cumulative distribution function f of x. So, questions you read carefully. If you are clear with questions, we'll go for the solution. Any doubt in the question, understanding the question? Please read the question carefully. Any doubt in reading it or understanding it, please let me know. The question clear to you? Any doubts in question so far?
No, sir.
Okay, so let us go to the problem. Similar to the bus, it is like elevator. Now we know the interval between 0 to 40 seconds. So straight away 1 by b minus a, it is 1 by 40 minus 0 because the range is from 0 to 40. 1 by 40, 0.025 is what we got. First one. Read the question and understand carefully. Write down the formula for the probability density function of the random variable x representing the variable. So like this. Calculate the probability that elevator takes less than 15 seconds. So less than 15 means what? 0 to 15 we need to calculate. So x minus a by b minus a, x value is 15 and a value for that limit is 0 from here. And below 40 minus 0, that will be 40. 15 by 40, it will be 0.375. That's the probability. If you convert into percentage, should do into 100, that will be 37.5 percentage. Okay. Third question C, calculate the mean and variance. Substitute those numbers in the mean and variance. Mean is what formula? So we got mean formula 40 minus 0 by 2. Mean formula, you check here mean. Mean is a plus b by 2, right? So 40 plus 0 divided by 2. Minus a minus b by 2. So it is like b minus a by 2, 40 minus 0 by 2. Just a minute, here it is minus is there, but actually is minus or plus?
Sir, plus.
Plus it is. So 40 plus 0 it should come, not minus, correct? Something wrong here. So anyway, 40 minus 0 or 40 plus 0, it will not make any difference. That's fine. So the answer is 20 seconds it will take mean value, average of that. Variance formula, you look at variance formula. Variance is b minus a by 2 whole square. But whereas mean it is a plus b by 2 from here, this one, a plus b by 2. And variance it is b minus a by 2 whole square. So 40 minus 0, 40 by 2, 20 square it will come. That's what variance is. Right? Square by 2. There is no square for this one here, sorry. So 40 minus 0, 40 square by 12, you get 33.33% is the variance. The cumulative function, so 0 to a, x value, x minus a by b minus a is what standard formula for this. That's what we wrote here. Right? So that's what third question stands. Fourth question. Look at fourth question. The total duration of a baseball games are uniformly distributed between 447 hours and 521 hours, inclusive. Both 447 and 521 are inclusive. Okay. So baseball, if you take about baseball, they are talking about find A and B and the discrete, what they represent. Write the distribution. Find the mean and standard deviation. the probability that the duration of games for teams between 480 and 500 hours. Okay, 480 hours and 500 hours. So same 445 to 525 what they given. 445 to 447 to 521. Sorry, 445 here somewhere 447 to 525 somewhere here. Uniform distribution. A value is 447. B value is 521. If you take the uniform distribution, it will be 1 by b minus a. So the difference of that will be 74. So 1 by that will be 0.0135. This is the uniform distribution we got. Next is what? Mean value a plus b by 2. Average of that 484 we get average. And standard deviation b minus a whole square by 12 is 21.36 we got. Same, right? So I'm not going in depth of because you understood that same kind of formula, same kind of techniques, right? Now here they gave 65th percentile, so they gave this value before itself, so they didn't give the value of x. So you can do it very simple. X minus 480 divided by 521 minus 447 will get the value of x. X value will be 495.1. Okay, you go through it once. You have any doubts with this, please let me know. Similarly, please go through the fifth question. The amount of time the service technician needs to change the oil in a car is uniform distribution. Between 11 and 21 minutes will take. Minimum time he can change the oil is 11 minutes, and maximum time he can change the oil is 21 minutes. Okay. Now, what is the random variable x inverse? So write the distribution and find that if it is greater than 19, how much time, how much it is taking. Greater than 19, and find the 50th percentile. So this is what they are given here. So we know that from that same things they have calculated. We can go to that. Okay. Seventh question also similar to that. Please go through it. Any doubts? Please bring it to my notice. I will discuss to that again. Okay. And question number 71 is similar to that. Just go through it. 71, 75. Any doubts are there? Let me know. I will discuss. Right. So we'll go to the next one. After uniform, we have next one called exponential. Please go through that all numericals. Any doubt in that, please bring it to my notice. You tell the question number, I will discuss once again. There's no problem because the same we are discussing, right? You feel uninterested in that. So to make you interested, we are going to the next topic, the exponential distribution. Exponential. You know that exponential means what? Exponent, e power something, right? E power 0, e power 1, e power 2. Exponentially it increases. So we'll tell that the graph is increasing exponentially or something like that. So let us see what is this exponential and what is the advantage of exponential. Okay. To go through this outcomes. So till now we have seen the exponential, the things which are a uniform distribution. Correct? Now, which one can we say is exponential? Let us say a person traveling in a lift, waiting for a lift is uniform distribution. The person changing the oil in car shed is uniform distribution. Right? All that uniform distribution. Can you give me one example? Exponential distribution means what? Any example where it will start at some point and it will not end at all. It keeps going on. Anything like that? An example. I just want you to understand some examples. You tell me whether it's right or wrong. We'll discuss. So this example, I feel it's exponential distribution. I'll give one example to you. Based on that, can you think it? Hello.
Yes, sir.
Yeah. One example is like let us say earthquake has occurred somewhere. Okay. And again, when the next earthquake will occur, like the amount of time from now until the next earthquake occurs. So we do not know, we cannot say, right? That is one example. And another example is like when we call someone, you call your nearest and dearest one frequently once in a week. You stay in a hostel, let us say. How much time you want to talk from now? We do not know. Correct? It may be 1 minute, 1 hour, 1 day. We don't know, right? So that's what is one of the examples. Okay. And now let us say you have changed your batteries in your remote. TV remote we have, right? You change the batteries. How long the batteries will come? We do not know. And similarly, you take the batteries in car or your bike. You have placed a new battery. How long the battery will be working? How long the battery will work? Right? All these things are like your exponential distribution type. Okay. So you got a clarity now. Can you build up some more examples? It's up to your imagination. Any of them?
Sir, cars moving in toll, sir.
That's what cars moving in toll. Yeah. See, it's like one event has to start and it has to go on. Yeah, fine. So cars moving on a toll on let us say festival day. We do not know. Let us say usually some 3-4 days holidays. Usually before COVID, if there are 3-4 days holidays, everyone would like to go to their native. Correct. In the toll gate, everything the traffic jam, complete jam. How do we find that probability? Means by this year this much is there traffic. Next year how much it can be there? How much? Okay, all that. And you know one more thing, like when you go to supermarket or anywhere, right? They'll ask you to send your mobile number. Correct? Experience that.
Yes, sir.
So why they take that? Can you say me? Why they do that? Can you know? Can you tell me? I'll tell some trade secret here. What they are trying to do. Hello, you can hear me? So we'll discuss that. Yeah, listen carefully. Let us say you went to a supermarket, okay, and you purchase some groceries or something. What you are purchasing, they are scanning it through barcode completely, right? Which means they are studying you. They are studying your shopping pattern. What time you will come? What time you will come? That also they will see. Means, you, for example, there is a new mall opened or new shopping online. Let us say you book through online. Let us say any online website you are booking. Swiggy, you are booking. So Swiggy, they know that on so and so day, Sunday, you'll order so and so breakfast. They know it before itself. So because they have studied that for 3 months, 4 months, 5 months, or they'll find out okay he's not ordering every day. Okay, he's ordering every week. Every week he's ordering, or every 15 days he's ordering. So what is your pattern? They are going to study. So that's what this engineering statistics is going to help you further. You become a data scientist, right? Data science is booming. When you become a data scientist, this is what you're going to do with the data. You will take the data and you will try to find those values and increase the probabilities or decrease the probabilities. Yeah, what I'm trying to say in simple for you is, so when you go to a supermarket, they'll take your mobile number and they'll find out what you are trying to buy there. Okay. So you are trying to buy vegetables, let us say, in the supermarket. So what they'll do on every Wednesday, they'll send a message to you stating that, yeah, today, because every Wednesday you are buying it, they'll send a message to you on every Wednesday stating that, yeah, today please come and visit our store. Today we have this offer, this discount. Like that, they'll give offer. And some of them will encash this way. When you are trying to buy a clothes, usually everyone will buy the clothes for their birthday. So go to a shopping mall and ask for a clothing, ready-made clothing. What they'll do, sir, what's your date of birth, sir? They'll ask. will tell the date of birth. Exactly 1 week before the date of birth onwards, they will start tracking you, sending a message. Please come and visit our store. The store is open from so and so time, so and so time. Because they know that time you are convenient, you are free. Because every time when you come to store, you come in that time only. Usually anyone will come from 4 to 6. From 4 to 6 again, which time you are comfortable? 5 to 6 or 5:30 to 6. What time you came to the store? So that time they will try to figure it out. So that's how they attract the customers back sitting at their home. So this all data will be stored to the database. From there, by doing this probability and statistics, they'll try to attract the customers during different distributions. So this is what we are trying to do, simple thing, but they will do their much more complicated data they have to handle. Okay, is that clear to you? You understood what is happening here? Now let us see the theory part of that. Okay, yeah. So consider a random variable x here, and then which is exponentially distributed with parameter, we call it as lambda. So this lambda is what? Failure rate slash the process rate. It can be a failure rate or it can be the process rate. This lambda can be called as a failure rate or can be called as the process rate. So then its probability distribution is going to be the standard formula here. So note down this formula. Fx of x equals to lambda e power minus lambda x when the value of x is greater than or equal to 0. If the value of x is less than 0, the value is 0. The value is x value is greater than 0 because we need to make sure that this lambda is your failure rate or process rate. Is lambda multiplied by exponential value e power minus lambda with the x parameter is like each parameter, each value of that. Okay, so that's how it is. So lambda e power minus lambda x. This will be exponentially increasing with the increase in value of x, and the value of x keeps increasing 0, 1, 2, 3, 4 like that. So this value also keeps increasing. Okay, that's how it goes on. Now we need to find out the area of that curve. What curve we have, right? So what is the area if you want to find? So we'll take usually the integrative from minus infinity to plus infinity. Okay, so with that we can take it only with greater than 0. So 0 and greater than 0. So 0 to infinity, let us take. This fx of x value is what? Lambda e power minus lambda x. So we replace that again. And x less than 0, it's 0 completely. We have ignored it. We have removed it. From 0 to infinity, minus infinity to 0, we are not taken. But 0 to plus infinity, we have taken. Because minus infinity to 0, it will be 0. So 0, if you add to this also, it will not make a difference. Right? So this is what it is here. Now if you do the derivation of that integral of this one, okay, lambda is a constant parameter, constant value, let us say, success rate of failure is a constant value. So lambda we have taken it out, and then e power minus x you take, it will be e power minus x by x. So this way you going to take it. So it will be e power minus lambda x by minus lambda. So lambda is again a constant parameter, lambda by minus lambda, and e power minus lambda x here, lambda value substitute into infinity. So e power minus infinity minus e power minus 0. So e power infinity is 0 and e power 0 is 1. So 0 minus 1, it's minus 1, minus 1, and minus here again, minus into minus plus. So the area of the curve we will get it 1. The area of the curve we are going to get it as 1. Okay. Cumulative distribution function. So CDF we call it as. So CDF, what will happen here? CDF. So they are given that value cumulative distribution function. So 1 minus e power minus lambda x. So it's all standard formulas. You need to remember those standard formulas. Of that are not given for us or not for the interest, because we are interested in the example problem, because applications we are interested. Correct? So they are not given these proofs of this all. Right? If you want, you can go through that training. Look at this one. If you want the proof of that, we check with this. The lambda is the rate of constant, the lambda value is greater than 0. We take that integral minus infinity plus infinity, fx of x into dx. So this value is what? Lambda e power minus lambda x, right? Lambda e power minus lambda x. We have taken that into consideration. Lambda e power minus lambda x. So if you take the time derivative of that into integral, okay, you're going to get 1 minus e power minus lambda. Minus e power minus lambda. Time derivative t we got. If you take into x in terms of x. Now, what is the mean and variance of that? So mean value, expected mean. So mean value, if you want to find, you need to take the area out of it. So take the area out of it, lambda, see here, minus infinity to plus infinity we are trying to find. Okay, and this formula we know that here, this lambda e power minus lambda x. So we take that here, lambda e power minus lambda x. Okay, x already is there, x we wrote here. As lambda is constant, we have moved out. We apply the integral now. X also is constant parameter. Take photo of the integral. So apply the integral for e power, and so it will come like this. To simplify it further, you are going to get 1 by lambda. It's all pure mathematics. If you know that how to do the integral better, right? We can go through this and net it out. We'll let you. Similarly, variance. Variance parameter u of x square minus u of x whole square. U of x square we got here is 1 by lambda. So minus this value 2 by lambda square. 1 by lambda minus 2 by lambda square. Okay. Right. I'm just trying to show you once again in the next class. I'm going to do the complete proofs of that. I'll do the step-by-step procedure how we have got this about. Okay, just for you to understand, because we cannot understand it by showing it to you. I'll write it on the notepad, okay, and I'll explain to you in the next class the detailed proof of that. As of now, I'm just trying to show you what it is and how it looks like. Okay, this got mean, variance, and standard deviation, all that. Let us see some examples of that. So roughly one example we'll see, and after seeing the proof of this one, we'll go for the next example. Okay. So let us take the time in minutes, say x, between the arrival of successful customers to a post office in exponential distribution with PDF. So they are told like x is, let us say, in time, and we expect some customers who are going to visit the post office. The distribution is given by 0.2 e power minus 0.2x. So based on that distribution, what is the expected time between arrivals? Okay, we are trying to find out from one arrival to next arrival. So what is the time they take? Like I told you, right? Shopping mall or supermarket, how frequently you visit is what they are trying to find. Daily you visit, or weekly you visit, or monthly you visit. What is the time duration? From 1 to 1 you are visiting the store. Here you are visiting the office is what they want to know. Now B, the customer arrives into the post office at 12:30 p.m. What is the probability the next customer arrives? So one customer came now. And what about the next customer who is going to come? What is the probability of that? Okay, 12:30 somebody came. Anyone will come at 12:32 or not? Within 2 minutes, some more person is going to come. Yes or no? Second, after 5 minutes, what is going to happen? Is what they are asking. Now the expected time between the arrival is lambda. So lambda is given here 0.2. How we can know 0.2 from this? Because f of x is what? Lambda e power minus lambda x. So that's what lambda value is going to be. Expected time between the arrivals, it is 0.2. Okay, so what is mu value? It is 1 by lambda. So mu is 1 by lambda from this. From this you can see here. From this proof, 1 by lambda is 1 by. That is mean value. U of x is the expectation, or x bar, or mu, which we got is 1 by lambda. So 1 by lambda we get here. So 1 by lambda means what? 1 by 0.2, which is 5 minutes. Okay. the expected time between arrival to the given by lambda 0,2, and the mean of that is 5 minutes. So what is that they're asking? What is the expected time between arrival? So the mean value we got as what? 5. So every 5 minutes we expect someone to come. Okay. B. First one. The next customer arrives before 12:30. Before 12:30. What is that they are trying to ask? It means that the time between their arrival and the previous arrival is almost 2 minutes. So 12:30 to 12:32. Correct? 2 minutes it is. So then 2 is the call. So less than equals 2 we need to find. So 0 to 2, lambda e power minus lambda x. The lambda value is 0.2, we know it here, substitute that in this. So apply the limits for that. We're going to get 1 minus e power this value, which is 0.33. So the next customer arrives is 33% probability. 33% probability is there that within 2 minutes the next person will arrive. What about this one? 5 now. It is not 2, it became 5. So the limits will become instead of 2, 5. So 1 minus e power 0.2 into 5. So it will be 0.36. So probability increased by 36%. Before it is 33%. Now it has increased to 36%. That within 5 minutes some more person may arrive. So I told you, right, one more example like your mobile phone battery, how long it will last, or TV battery or car battery, like that they are trying to find out here. On certain computer parts last 10 years, they are trying to find out. The length of the time the computer part lasts is exponential. You bought a new computer today, from today, how long the computer parts will be working without replacing them. Or today you buy a new car, if you to buy a new car and what's the time taken to replace the parts, new bike, new car, new computer, whatever, all that they are trying to find the analysis. So because so based on this analysis, the computer manufacturing company will keep the spare parts available. Let us say you have got a brand new mobile phone. The brand new mobile phone does not require any of the spare parts in 1 year or 2 years because nobody is going to replace them. So no need to manufacture them. Very less probability. Why? How they do that? How they know that? So based on their previous experiences. Okay. So they try to find the data, and then based on that data, what they got, they'll manufacture the spare. So that's how this probability will help them. Correct? Are you understanding the concept here? If you manufacture a new computer or if you manufacture something a very new brand new car, you will do the probability analysis from the expert engineers with the data science engineers, and okay, they'll decide like yeah, within 3rd year to 4th year we can start manufacturing the spare parts for this. Okay, or you can say like after 10 years or 20 years, no need to manufacture the spare parts of this because those cars doesn't exist now or those bike doesn't exist. Or let us say you take Nokia 1100 phone. Do you think Nokia company will still manufacture the spare parts for it? So nobody is using that mobile phone, let us say now. So very less number, so they don't manufacture that. And even you take Windows operating system, Windows 7, Windows 8, Windows 10, all that we have different numbers, whatever it is. So they will stop supporting that because from the data what they have, let us say out of 100 crore operating systems what they use, okay, only 10 lakh people are using Windows XP. Then will they have to give the support? Because if they want to give the support, they need to do a lot of R&D. It will do a lot of cost for them. So what they'll do, they'll tell like, yeah, from next year so on so time, you are not going to give any support for them. You need to upgrade your operating system is what they will tell. So this is how the interface will work based on the probability. Okay. Those people are working behind us with a lot of data science engineers or big data engineers, right? So all that high level profile, high profile work they will do with this data. Okay, that's their job. They keep studying the data and based on the inputs of the data. Every quarter or 1/4 of the year, they'll discuss about that. What's the next plan? So let us see this question B. Second question. We look at the second question. We straightforward question. So mu value is 10. We know it. How U value is 10 because they are given there 10. Correct? Where they are given 10 years they gave the computer part average. Average means mean. So mean means mu. Mu is 10, lambda is 1 by mu. So lambda value will be 0.1. So if you want to find that for 7 years, first question, probability of computer pass more than 7, value will be 7. So this one is 0.1, which is lambda. Correct? Lambda value is 0.1 and into 7 we get. Because this formula how we got from this 2. 1 minus 0.2 into 2 we got here. There it is. Here also you see 2 we got 2, 5 we got 5. But what about this one? It is 7. So we'll get 7 here. Okay, so this becomes e power 0.7. We'll get around 49.66%. The B question. So now, on average, one computer parts last 10 years. Therefore, 5 computer parts, if they are used one after the other, last. The average is 5 if they use like that. 5 times if they use. One spare part 10 years, second spare part 10 years, like that if they use, we get 50 years. Okay. So that's what B question is. C question, they are trying to find the 80%. 80% is going to find. So P of x less than k. K value is what? 0.8. So K value is given here 0.8 here. Now we want to find this K. Okay. 80% they gave, K they didn't give. We have to find the value of K. How to find the value of K? E power minus 0.1 is this lambda value into K equals to 1 we know it minus 0.8 it is 0.2. Okay. So e power it is, so you apply the law for that, you're going to get 16.1 years is the probability of that. So between 9 and 11 years you want to find, so this is the formula. 11 and 9, subtract those two, 66 minus 15 is 0.707%. So this is how the questions will be on exponential distribution. So look at the third question. Just I'll show the question to you. To try to solve the question, on average, the pair of running shoe can last for 18 months, used every day. The length of time running shoe lasts is exponentially distributed. What is the probability that a pair of running shoe lasts more than 15 months? On average, how long would 6 pair of running shoes last if they are used one after the other? And 80% of the running shoe lasts at most. How long it is used every day? Is that question. Go through the question carefully and understand this problem. Then right away. Very simple, same pattern. Fourth question. The job arrive every 15 seconds on average. Lambda is 4 per minute. What is the probability of waiting less than or equal to 30 seconds? That is 0.5 minutes. What is the maximum waiting time between two jobs submissions with 95% confidence? Understand these questions. They are very interesting questions. It will help you a lot in your real world scenario. Okay. So next class we will see the Gaussian distribution. Along with this Gaussian distribution, I will discuss you the theoretical proofs for exponential as well as the Gaussian. So both of them we will try to see and understand these Gaussian distributions. Gaussian distribution problems. You see one problem for each. After that, we can go to multiple problems. Okay. Don't see all the problems at the same point of time. Get confused. One you see. After that, one by one, we will see the questions. So, mean and standard. Okay. The next class will begin with the normal distribution, and along with that, I will do the derivation and proof for the exponential distribution, and we will see some more problems on that. Okay. So here you are.
Yes, sir.